Okay, so this is using the Moivre to prove a trig identity. Phil McGrain, the brilliant student that Phil McGrain is, has predicted this is coming up in 2020. If you go back and look at some of the other videos on trig identities, there's a similar type of solution to cos 2 theta. If you remember from before, to get cos 2 theta, we would have to have cos theta plus I sine theta to be squared, which would give me cos 2 theta plus I sine 2 theta. And then we could use my trig identity to multiply out this bracket and equate the real parts. Now in this question, we're going to be equating the imaginary parts. So if you imagine sine 3 theta, similar vein of this, we're going to have to raise it to be cubed. So the Moivre is where if we have cos theta plus I sine theta to be cubed, that becomes cos 3 theta. Now, or would be 1 here, so we'd have a 1 cubed. It's not going to affect the answer. Plus I sine 3 theta. That's what that guy would be. So if we now multiply out these brackets, there's going to be 3 of them, and equate the real part, or the imaginary parts, we should get I times this guy. So let's multiply cos theta by I sine theta. What are we going to get? And then we'd have to do it a third time. I'll put it in here. So we're going to get cos squared theta plus cos theta I sine theta plus I sine theta cos theta plus I squared sine squared theta. Now you guys, you know there's going to be 2 of these in the middle, so you could do that quite quickly, and you know this is going to be a -1. So you can go straight to this line from the first multiplication. Cos squared theta plus twice cos theta I sine theta minus sine squared theta. Now we're going to multiply this by this one, cos theta plus I sine theta. So we're going to get cos cubed theta plus cos squared theta I sine theta plus 2, this one by this one, 2 cos theta by cos theta, so 2 cos squared theta I sine theta. And then we're going to have the sine squared part, so plus twice cos theta I sine squared theta. Just check that, 2 cos theta I sine theta by I sine theta, so there's going to be a squared in there too. And then the last two, quite a wide page required here, we're going to have minus sine squared theta by cos theta, and we're going to have minus sine squared theta by I sine theta, which is minus I sine cubed theta. Now, the only parts we need are the imaginary parts. This one has an I in it. This one has an I in it. This one has an I squared in it, so we don't need this one, because the I squared will go to -1. And do we need, this one has an I in it as well. So there should be a multiply there. No, my apologies. Just get rid of that line. I was misreading it. It's just this one. That one is not part of the last one. So we've 3 parts. So just let's write them down separately. Cos squared theta I sine theta plus twice cos squared theta I sine theta. We'll take the I out now in a minute. Minus I sine cubed theta. Just remind ourselves what we're looking for. 3 sine theta minus 4 sine cubed theta. Okay, so let's take that I out. Here's my I, and we're left with cos squared theta sine theta plus twice cos squared theta sine theta. Cos squared theta sine theta. So we've 3 of them. Minus sine cubed theta. Now if you jump back up, we want sines only, so we want to eliminate these causes. So we're going to use the replacement method for cos as the one we're going to change. So what have we got? we have I times 3 of these, 3 cos squared theta sine theta minus sine cubed theta. And if you remember from the trig identities video, well, there's several things we could replace cos squared with, but because we want sine, cos squared theta plus sine squared theta is equal to 1. So we're going to replace that cos squared. So cos squared theta is 1 minus sine squared theta. So let's see, will that help us in here? So we're going to have I times 3 times 1 minus sine squared theta, and I still have that sine theta there, minus sine cubed theta. So we're going to have I times 3 minus 3 sine squared theta by sine theta minus sine cubed theta. So it's I times this 3 by this sine theta, 3 sine theta minus this one by this one, 3 sine cubed theta minus sine cubed theta, which is going to be I times 3 sine theta minus 4 sine cubed theta. Now hopefully that's what they were looking for. 3 sine theta minus 4 sine cubed theta, 3 sine theta minus 4 sine cubed theta, using the Moivre to show or to prove a trig identity.